The last session we started topic 7, which is about the chemical reactions. And this chemical reaction is divided into subtopic. The first one is physical and chemical changes. A physical change, the one which no new substance is formed, whereas chemical change, the change in which new substance is formed. Like example, melting of ice is a physical change, but burning of a candle wax or burning of a wood is a chemical change. In the second part, we have discussed that is about the rate or the speed of the reaction, like how fast the reaction proceed or how much time the reactant will take to form a product. We call that as speed or rate of reaction. If you want to calculate the rate, like it can be calculated by amount of a reactant used divided by time or amount of a product formed divided by time interval. We can work out the rate in different manner. Like example, if a precipitate is formed or if a solid is formed during a reaction, we can work out how much time the solid will take to disappear. Or if a gas is given off during a reaction, so we can allow that gas to escape, so we'll know how much mass change in mass occur. Otherwise, we can measure the volume of the gas directly to get the rate of reaction. Then there are certain factors which affect the rate of reaction, changing a temperature, concentration, surface area, using of a catalyst. These are all the things which alter the rate of reaction. This is what we have discussed in the last session. Then there are some reactions which can only occur in the presence of light. So we call them as photochemical reaction, such as development of the photographic plate or photosynthesis. These are photochemical reaction. The reaction basically depends on the light intensity. Greater or light intensity means faster or greater rate of the reaction. Then topic 7.3 is known as reversible reaction. What is the concept or what is the meaning of reversible reaction? There are some reactions in which the reactant can form a product and the product can decompose to form back the reactant. We call them as reversible reaction. Example, so reactions, there are some reactions, not all of the reaction, there are few reactions. The reactions in which reactants can form a product and the product can decompose to form back the reactant, and we call them as reversible reaction. But again, I repeat, this is not happening for all the reactions. There are few specific reactions are there which are reversible, but most of the reactions are irreversible. So whenever we have a chemical reaction in terms of direction, a chemical reaction can be irreversible, it can be a reversible. So what is the difference between reversible and irreversible reaction? In irreversible reaction, the reactants are there. These reactants can form a product only. And then the product cannot form back the reactant. But in reversible reaction, what can happen? That we have reactant, they combine to form a product, and the product can break down and form back the reactant. So whenever we want to distinguish between reversible and irreversible reaction, for irreversible reaction, the arrow is pointing only in one way, one direction. Whereas reversible reaction, the arrow is pointing both ways. Like what it means that the possibilities are there that the reactant can form a product or the product can decompose and form back the reactant. Some examples of reversible and irreversible reactions. Like example, if I say we have carbon or coke is there, it reacted with oxygen. So when carbon combined with oxygen, it formed carbon dioxide. But this carbon dioxide cannot decompose back to carbon and oxygen. This does not happen. So if the reverse cannot happen or reverse cannot occur, what we call this reaction, we call that as irreversible reaction. But our main topic is reversible reaction. What is the concept of the reversible reaction? Reversible reaction means the reactant can form a product and the product can form back the reactant, and we call them as reversible reaction. Is it clear that first the difference between reversible and irreversible? Any doubt till this point? Now some examples of reversible reactions, and you have to learn these examples because in exam they ask state the change that occur. So there are some examples of reversible reactions. If we say copper sulfate, anhydrous copper sulfate, CuSO4, you have to learn the color also. Copper sulfate, which is solid, and we add a small quantity of water. Like example, we only add 5 water molecules. Like it's not too much, it's only 5 water molecules are added. Copper sulfate is an ionic compound. And what is the color of this copper sulfate? This copper sulfate is white in color. But when we add water molecules, 5 water molecules are added. As a result, what we observe, CuSO4 dot 5H2O. What we call when we are writing as a dot 5H2O, it means this is called a water of crystallization. What happened here, like copper sulfate is an ionic compound. Ionic compound exists as a lattice. Like there will be a positive and negative ions in the structure, and we call that as lattice. But what is the meaning of this dot 5H2O when we are writing dot 5H2O or dot 3H2O? So it means that there is a lattice. This is also a solid, but it trapped water molecules. And how many water molecules are trapped? It has trapped 5 water molecules. So when we write for this 5H2O, it means 5 water molecules are trapped. 1, 2, 3, 4, 5. Like inside or around it, there are 5 water molecules which are trapped in the lattice. So the salt which does not contain any water of crystallization, we call that as anhydrous. And the salt which contained water of crystallization, this H2O is called water of crystallization. So this is called a hydrated salt. So both are solid, hydrated and anhydrous salt, both are solid, but only difference is that anhydrous salt does not contain water of crystallization or does not trap any water molecule, whereas hydrated salt contain water of crystallization or they trap water molecules. So when we add like example, and it's like only 5 water molecules are added. So for a 1 molecule of copper sulfate, when we add 5 water molecule, the salt, this water, 5 molecules of water are not sufficient to dissolve. So the crystal, the lattice trap the water molecule, and we call that as a hydrated salt. But when we supply heat energy, like example, so originally it is white in color, but when copper sulfate trap the water molecule, it changes the color to blue. Now, if I supply the heat energy, if I heat this anhydrous salt, hydrated salt. So when I supply the heat energy to this hydrated salt, what happened, what I will see or what I will observe, because when we supply the heat energy, the water evaporate or water will be removed. So the moment we supply the heat energy, these water molecules will go out. And as these water molecules will go out from the lattice, it will turn back to anhydrous salt again. So when we add water, it is hydrated. Like when we add a very small quantity of water molecule, it is hydrated. But when we supply the heat energy, the water molecules are being removed and it turned into anhydrous. So as you can see, the reactant can form a product and the product can form back the reactant. So what we call this reaction, we call this as reversible reaction. Is it clear, this example of reversible reaction? That the reactant are forming a product and the product can form back the reactant again. So whenever you have hydrated and anhydrous salt, these reactions are always reversible because a water molecule can be added or water molecule can be removed. Another one which you have to learn for the course, that is cobalt 2 chloride. So cobalt 2 chloride, CoCl2. Yeah, the color will change to white. That's true. When we supply the heat energy, the color will change because the water molecules are being removed, so it will turn into white again. So if you add water, it will turn blue. Here, when we add water, it turned blue. When we supply heat energy, it will change its color from blue to white. So the reactants are forming a product. A product can decompose and form back the reactant. That's why we call that as reversible reaction. Another example, like we have cobalt chloride, CoCl2. And now what we are doing with this cobalt chloride, we are also, it is anhydrous. You have to learn, again I repeat, you have to learn the color for these two examples. One is anhydrous copper sulfate, changes from white to blue or blue to white, and cobalt chloride is from blue to pink. So when cobalt chloride does not contain any water, it is blue in color. Different salts can have different color depending on the type of elements present. So that is blue in color. When we add water molecule, example, we add 3 water molecules. So as a result, when it trapped the 3 water molecule, it turned into CoCl2 dot 3H2O. As it turned into CoCl2 dot 3H2O, so it trapped 3 water molecule, and different salts can have different number of water of crystallization because of the size of the lattice and the size of the ions. So here cobalt chloride is able to trap 3 water molecule. So when it is able to trap the 3 water molecule, it turn into pink. So it will change its color from blue to pink. But when I supply the heat energy, if I heat this pink salt, as a result, the water of crystallization, it will lose its water of crystallization. And when it loses the water of crystallization, it will turn back to blue again. So reactants, the cobalt chloride can form hydrated, and hydrated one can turn back into anhydrous. So what we call this reaction, we call that as reversible reaction because the reactants are forming a product and the product can form back the reactant. Is it clear? The second example of anhydrous cobalt 2 chloride. Then for reversible reactions, For when reversible reaction is there, we use a specific term. We use a specific term. We say equilibrium. The term equilibrium means balance or not in equilibrium. Or shifted equilibrium. What is the meaning of equilibrium or shifted equilibrium and not in equilibrium? Basically what happened, as we know in reversible reaction, the reactants are there. In reversible reactions, how to represent, like arrow should be pointing in both ways. So we know the reactants can form a product and the product can form back the reactant. Like example, if we have say 1 gram of reactant is forming a product and at the same time 1 gram of a product is forming back the reactant. So what we call, when there's a balance, like amount of product form is same as the amount of reactant form. So what we call this condition as equilibrium. So the equilibrium means that rate of forward reaction, the forward one which is towards the right, so rate of forward is equal to the rate of backward and no change in concentration of reactant or product. Like the amount of the total amount of reactant and product will not change as it undergo the same way. We call this as equilibrium. Example, I will give an example for how we explain the idea of equilibrium. Say you have reactant and that reactant is forming a product. So we have example 4 grams of reactant and we have example 6 gram of product. Example, at certain time, after certain time, we have 4 gram of reactant and 6 gram of product. Now what happen if I say out of 4 grams, 1 gram of a reactant is forming a product and at the same time 1 gram of a product is forming back the reactant. What is the change here? Does anything change? If 1 gram out of 4 gram, 1 gram of a product is formed from the reactant and out of 6 gram of a product, 1 gram form back the reactant. So what will be the overall change? There will be no change. So whenever we don't find any change in reactant and product amounts and the speed of the forward and the backward is same, what we call that the reaction is balance or reaction is equilibrium. But if it is not balanced, like example, when we have reactant and product, so we have reactant and product. If I say that 1 gram of a reactant is forming a product, but half gram of a product is forming back the reactant, is this equilibrium balance? The second example, is this equilibrium? Yes or no? So it is not in equilibrium. Why it is not in equilibrium? Because the reactants are forming more product, whereas product is forming back the reactant small quantity. So we say it is not in equilibrium. And when it is not in equilibrium, we normally use the term shifting of the equilibrium. Equilibrium has shifted. Like we say shifted towards right or forward or backward. So in this case, because the forward, like the formation of a product is more than the reactant, so we use the term, we'll say the equilibrium, I'm writing in short EQ, equilibrium is shifted towards the right hand side, or we can say forward. Equilibrium shifted towards right or equilibrium is shifted forward. Is it clear? Because the reactants are forming more product, but a very small amount of quantity of a product decomposed to form back the reactant. So if the right hand side it is faster, like greater amount, we say equilibrium is shifted towards right. And opposite will happen if we have reactant and the product. When I say 1 gram of a reactant is forming a product, but as a result, 3 gram of a product is forming back the reactant. Is it equilibrium? Yes or no? Is this reaction is in equilibrium? So it is not in equilibrium because it's not balanced. The reactants are forming at a different rate and the product, yeah, that's right. Then if it is not in equilibrium, then we use the term equilibrium has shifted because the left hand side, so we can say if something is not in equilibrium, so we'll use the term that equilibrium shifted to left side, or we can say backward. So left side means backward and right hand side means forward. So whenever you have a reversible reaction, then there are three possibilities. Either it will be in equilibrium, either it will be balanced. So for a reversible reaction, what are the possibilities we have? So for a reversible reaction, what are the possibilities we have? Number one, it might be in equilibrium. It might be equilibrium shifted towards right, or it might be equilibrium shifted towards left, or we can say backward, and if equilibrium is shifted towards right, we will say forward. So these are the terms which we have to use whenever we use the concept of equilibrium. Basically, B and C means not in equilibrium, and when it is not in equilibrium, then there are two possibilities, that either the equilibrium will be towards the right hand side, shifted towards right, or equilibrium will shift towards left hand side. Now, the factors, there are things which can affect the equilibrium. So the factors which affect the equilibrium, number one is the amount of reactant or product that can have effect. Number two, the temperature. And number three is the pressure. But this pressure is only valid for gases. So there are three things which can affect the equilibrium. Number one, the amount of reactant or product added or removed, that can affect the equilibrium. Number two is the temperature. When we change the temperature, the equilibrium can be affected by change in temperature. And number three is a pressure, and that pressure is only valid for gases. Like if we have either one or two or gaseous reactant or product, then only the pressure will affect the equilibrium. So there we are talking about equilibrium. The rate is affected by concentration, rate or speed of reaction is affected by concentration, surface area, temperature, and catalyst, and some of the photochemical reaction, light as well. So example, the factors which affect amount of reactant and product added or removed, temperature and pressure. Now we'll discuss each of them. What is the effect of changing reactant or product on equilibrium? Example, if we add reactant, there is a reaction mixture and we are adding a reactant. Say you have initially the reactant is there and product. Example, 4 grams of reactant, and example 10 gram of a product. But in the beginning it is in equilibrium. Like say 1 gram of a reactant is forming a product, at the same time 1 gram of a product is forming back the reactant. This is originally it is equilibrium. Now what we are doing, if I add reactant, it is in equilibrium. Now if we add reactant, if we increase the amount of reactant, like I make it double. It was 4, the reactant was 4, but what I made it 8 grams. I make it double. So if 4 gram is forming 1 gram of a product, so 8 gram, the double amount will form double amount of product. So 8 gram will form how much? It will form 2 grams of product. So if 4 gram is forming 1 gram of a product, if we add reactant, like we increase the amount of reactant, only amount of reactant, product we did not change. Only the amount of the reactant we change. We add more reactant, like we double the amount of reactant. So the rate at which the product is forming, that will also be doubled. So the product does not change initially when we add. The reactant has changed. So the product is forming 1 gram of a reactant, but the reactant formed 2 grams of a product. So where the equilibrium is shifted, which direction equilibrium is shifted when we add reactant? It is right or left? So equilibrium is shifted towards the right hand side. So what we call that equilibrium has shifted, or the reaction is shifted towards the forward direction. So whenever we add reactant, what we'll observe, when we add reactant, the equilibrium will shift towards the right hand side. Is it clear? The first part, if we add a reactant, what will happen? Any doubt to this part? The second part, if we remove the reactant, The first one were adding a reactant, and the second one we are removing the reactant. So we have reactant, like in the beginning the reaction is in equilibrium, so we have reactants, and the reactants are forming a product. So reactant form a product, the product can decompose and form back the reactant. Say I'm using the same example, say 4 grams of reactant were there and 10 gram of a product is there. When it is in equilibrium, say 1 gram of a product is formed by reactant, and at the same time 1 gram of a product decomposed to form back the reactant. So originally it is in equilibrium. Now what we do, we are removing the product, removing the reactant. So if we remove the reactant, like we have 4 gram of reactant, but instead of 4 gram, what we did, we make it half. Like it was 4, we make it 2. So 4 gram of a reactant were forming 1 gram of a product at once. But when we have half of that, the 2 gram will only form half of what it is forming. So if 4 gram was forming 1 gram of a product, then 2 gram will form half gram of a product. But the amount of the product does not change here, so it will follow the same rate. So as you can see, the forward has decreased and the backward has increased. So what will be the effect on the position of equilibrium? So equilibrium will shift towards left hand side. So we say equilibrium is shifted towards left, or you can also use the term backward. So left hand side or backward is the term which we use for equilibrium when we remove the reactant. Is it clear, this part? Any doubt? Then what else we can do if we remove the product? So if I simply write in terms of table, the same concept, same idea is used. The first part in the first column we have effect like change done, and the second one is shifting of equilibrium. The change what we made, like example, if we add reactant, more reactants are there, less product, so equilibrium will shift towards right or forward. If we remove reactant, then the equilibrium will shift towards left or backward. And opposite will happen if we add product, equilibrium will shift towards left or backward. And if we remove product, equilibrium will shift towards the right or forward. So this is a simple table which you, if you learn, that will be best, that you don't have to just bother about it. Adding a reactant, like if we have more reactant, basically what happened, it's a balance. Like the side where you will have more, it will shift towards the opposite one. Like if we add reactant, so reactant side is heavy, so it will shift towards the forward. If we remove reactant, so the product side is heavy, so it will shift in opposite direction to make a balance, so it will shift towards left hand side. If you add a product side become heavy, so it will shift towards left hand side. And if you remove the product, it will shift towards the right hand side. So The side where smaller quantity is there, that side it is shifted. Then effect of temperature on equilibrium. So what is the effect of temperature on the equilibrium or position of equilibrium? So we have reactant, in terms of temperature, reaction can be endothermic or it can be exothermic. So if the reaction is endothermic and we increase temperature, where the equilibrium will shift, it will shift towards the right hand side or forward. And if the reaction is endothermic and we are decreasing the temperature, so it will shift towards the left or backward. And opposite will happen if a reaction is exothermic reaction, a reversible reaction is exothermic. So when we increase the temperature, it will shift towards left or back. And if the reaction is exothermic and we are decreasing the temperature, it will shift towards the right hand side or forward. So it depends on the type of reaction, because in terms of chemical energetic, the reaction can be endothermic or it can be exothermic. Endothermic reactions, if you increase the temperature, it will shift towards the right, and if you decrease the temperature, it will shift towards left, the equilibrium or the balance. For exo, it is opposite. If you increase the temperature, equilibrium will shift towards left, and if you decrease the temperature, equilibrium will shift towards right hand side. So if I say there's a reversible reaction which is endothermic, for when we say endothermic, we are talking about the forward one, like example CuSO4 dot 5H2O. If we have this first hydrated and it turned into CuSO4 plus 5H2O, and the reaction, the forward reaction is endo. Now what I do, I supply heat energy or I increase temperature. So if I supply heat energy or I increase the temperature, it will start to lose the water of crystallization. So when it start to lose its water of crystallization, where the equilibrium will shift, the equilibrium will shift towards the right hand side or forward. So as you can see here, if the reaction is endothermic, endothermic reaction means that it absorb energy when the change occur. So when we supply heat energy, when we increase the temperature, the balance or equilibrium has shifted towards the right hand side. I'll share another link and continue this discussion.